Built-in functions. This is a topic that's really important in computer science because computer science is built on problem solving, and the main strategy for problem solving in computer science is about dividing things into smaller bits that are manageable and then putting them together. It's a strategy we call divide and conquer. Building functions is all about those little pieces that we're putting together. If we can come up with a series of events that when used together in a certain order will solve a problem or a small piece of the problem, then we can put that series of events together into a function. And we're lucky that a lot of people have already done that for us in Python, and they've built in functions that we can use. I'm going to talk about these functions and how we use functions together with other functions. You can make your own, but we're concentrating right now on the ones that have been made for us.
We're going to start with the basics. You can think of functions as having some input, then some processing, stuff happens in the box, and then they'll generate us output. So they'll eat up that input and use it to create the output that we're looking for. Some people like to think about the input as being something the function is going to consume. It doesn't need input, but if you allow input into a function, then you can have the function react differently based off of what input you're giving it. We're looking for at most one thing that the function will produce in the end. And again, it doesn't have to give us anything back. But if it does, we can't have more than one thing that it gives back. Why does it not have to give us something back? Because it can print to the screen, it can look for input, it can make changes to values inside that function box. So maybe what we're looking for isn't a value to be given back to us, but something we want to see on the screen.
Back to what I was talking about with the smaller chunks working together to solve a larger problem. If we have separate functions performing each little piece of a task, this function that we solved over here can actually feed into the next. So one function can produce output, which will be the input to the next. In that way, we can take the output from each function, join them together, and solve our larger problem. But just solving and defining the function isn't all we have to do. We have to decide, when do we want this to happen? We have to call the function. So if we want, how we define those lines of code to actually execute, if we want that to happen, we have to decide where in our code we're actually going to execute that function and call it. We call it calling the function, a function call. That function call, there's two different ways that we can set up our input. One way is with dot notation, so we put whatever our input is in front of a dot, and the other way is to include it in the brackets. Now there's specific reasons we have two different ways of giving the input, and that's not something we're going to go into right now. But you do need to realize that when you see something in front of the dot, it's the input for our function. The function call is what name you see after the dot. And what's in the brackets is also input. It's just used in a different kind of way inside the function. Don't worry about it too much for now, but recognize input when you see input.
If you see the term module or modules, just keep in mind we're writing functions. They're all probably very small, but often you have functions that are related. And when you have related functions, it's easiest to find them if they're all together in the same place. So we'll put all the functions that are related into the same module. So for instance, what you see on the slide is a bubble with a lot of different things that can be done with strings. And those are all functions for strings, and they're all found in the same module. I put this slide in because it's important to know how to look stuff up. If you are having trouble because you can't figure out, oh my goodness, what functions are there for the math? What functions do I have for strings? You can actually type an instruction into the Python environment to tell you. So this is just for your own reference. If you forget how to do it, you can come back and look it up. Data types is a very important concept in programming. We as people understand data types because we've been conditioned and recognize when somebody's talking about a number of things versus just speaking a language. In programming, we have to tell the computer, to tell the program what type of thing it's dealing with. And it's kind of interesting because just like we can recognize a person versus an animal of like a dog or cat, we can create different types for our program as well. But that's for another chapter. So looking at the data types we've already been using, a float, a number with a decimal point, str, which is a string, or int, these three different kind of functions are used to change. So if you have a 5, but you want it used like a string, then you can put str in front of the 5 so that now you can join, you can concatenate 8 with 5. But if you want that 8, which is a string, to be added to 5, you can now convert that to an int. So you can add 8 plus 5. So float, str, and int are all functions that can be used with one type of a value to convert to another. But be careful. Don't try to convert a string value to an int if it's not able to be an int. So don't, for instance, try and take the name Fred and turn it into an int, because Fred is not something that we can see as an integer. Remember this question? You were asked to check off all the different instructions that resulted in a floating point number. Again, we're looking at data types. Square root, the math.sqrt returns a floating point number. The 1/ for a division question returns a floating point number, but 2 gives you an int. And if you have a number with a decimal point in it already and you use it in a calculation, you'll return a floating point number.
Remember this question? And remember I said you can take one function and feed it into another? Well, we're kind of doing that here. We're taking a string value minus 2.2 and we're turning that string into a float. So we're getting rid of those string quotes around the value and we end up with a negative 2.2. But then we're taking that output, the result from turning our string to a float, and feeding that input in to get an int. So now we have to stop at that decimal point and drop everything including the decimal point, and we're left with minus 2. Did you get that answer right?
So this was an interesting question. It said, what single change can you make in order to get that line of code, print dir pi, to actually run? So to get it to run, you have to import the pi value from the math module. But if you include all of the math module, then when you refer to pi, you have to say math.pi. So importing all of math, the whole module with all of its functions, you have to also make the change that you're going to get pi from the math module, so that math dot. So the correct answer, a single change, is to say from math you're going to import pi. You're importing one thing, so now you don't have to say math.pi, you just say dir pi. This, by the way, is not something that I will make you guys memorize and learn and be able to repeat back to me. This is just something that's good to know, because if you see an error message come up when you need the math.pi, it's just something that's going to trigger in your head and say, oh, I imported the whole math module, so I now have to say math dot and understand what the error message is. Okay, now let's get into some specific functions just for the numbers. So math operators work the same as they always have your whole life. addition, subtraction, multiplication, division, you're going to understand them in the same way you learned them in math class. The only new thing here is modulus. That is a math operator that your math teacher should know about. It's specifically used in computer science because it's often a strategy that we use when we're looking at patterning of things. So I will keep bringing this up from time to time, and we'll talk more about it in another time. So the last screen had the operators that we always use, and they work the same, including BEDMAS, by the way. But this slide shows you square root, power, and again, a modulus function. But now it's drawing the lines of code from a function that's included in the math module. So kind of weird again. There are two different ways that you can do modulus. What is it doing, by the way? I'm going to tell you now. 14, 12. What it's saying is take all the groups of 12 you can out of 14 and tell me how many numbers are left. So if you take 12 out of 14, you're only left with 2. Well, when you use the modulo, the fmod function from the math module, it gives you the answer back as a floating point value. So that's interesting to note too. If we go back to the previous slide, which I can't do right now, I think you'll see that if you take a look back at it, I think you'll see that the result from that percent sign, which is also the modulus or the modulo function, you don't get a floating point value, you get an integer value. I'm willing to bet there's somebody in the class who has memorized a lot of digits for pi, but there's only so many digits that are available on a computer. The math.pi value has as many digits as can be recorded in the computer. So you don't have to memorize all of those digits. It's already set up for you, which is kind of nice, and it's very accurate. We use exponents a lot in our mathematical calculations. So they have made that POW function available all the time. So you don't have to import math to get POW. ABS, it's not talking about your brakes on your car. That's absolute value, and it's not something you use until the higher grades in math class, but it's an absolute value, and what it's telling you is how far your number is from 0 on a number line. So you can think of it as taking any number and just making sure you've got the positive value of that number. So if you start with a negative number, you're going to get a positive. So -3 will give you a positive 3. If you have a positive 3 to begin with, it doesn't do anything because it's already positive. So again, lots of ways of finding the square of a number. You can multiply the number by itself. You can use the **2. That's again finding the exponent. You can use the POW function, or you can actually specify you're getting the POW function from the math module. And notice again, if you say math.pow, you for some reason get a floating point number, where if you don't use the one in the math module, you get an integer value. I'm not going to ask you that on a test, but just be aware if something weird is going on with your numbers and you're noticing that for some reason you're getting integers but you need it to be more accurate, that could be your reason why. You will need to remember though that if you import the entire module at the top of your program, then you will have to put the math dot or that module name dot in front of the function you're using. If you import only the function, you don't need to have the module name with the dot. Now let's take a look at the built-in functions for strings.
So what's a string? A string is just a series of characters. Now those characters can be pretty much anything you see on your keyboard. Yes, they can be digits. Yes, they can be punctuation. Yes, they can be letters, both uppercase and lowercase. and you put them together and put quotes around them, and you have a string. Okay? Strings have certain characteristics. For instance, those characters come in a certain order. So the first character is at a position in your string. That position we call an index. And being computer science people, we don't like anybody left out. So we want to use our digit 0. We don't want him left out. We're going to put him at the beginning. We always use 0. So the first position, position 1, is actually index 0. That's weird, but true. And that makes another problem. When we get to the last index, is that index going to match the length of our string? No, because we started at 0. We counted 0. So the length is actually 1 more than the last position, the last index in our string. So if we have a length of, say, 10, we're going to be going from index 0 up to index 9 with a length of 10. So keep that in mind. It can be confusing until you get used to it. After you get used to it, it's not a problem at all. The other thing to remember is you need to have your string values in quotation marks. I call them string quotes because when you do Java programming, we always have string quotes as those double quotes. The single quotes are reserved for something else. But in Python, it doesn't matter which set of quotes you use. I'm going to use double quotes for my strings because I don't want to confuse people when you get to doing the Java programming. Okay, but if you see something in single quotes in Python, it still is a string.
There's something called overloading, and that plus sign is overloaded, which means it has two different things it can do. If you have numbers, you're adding. If you have strings, you're concatenating, which means you're going to stick the two strings together to get a new value, which is both things together as one string. Okay, so concatenation is joining two strings into being one bigger string. LEN, that's how you get the length. We talked about the term called index. If you see those square brackets, it means you have an index. Within the square brackets on the screen, you see a 5. So if we count each character, so the T as in index 0, the H as an index 1, the I as an index 2, the S as an index 3, the space, don't leave out the space, as an index 4, the I for is actually an index 5. So if you want to print the character at index 5 for that string, you're going to get the I. Okay, so here's a problem. We have that plus sign. Remember I told you that the plus sign could either work as a concatenation operator for two strings, or it could work as an addition operator for two numeric values, either floating point numbers or integers. Well, in this case, there were is a string. A 5 is an int. And so that plus sign doesn't know what to do. It doesn't know whether it is a concatenation operator or if it's an addition operator. So you get an error message. I don't know if you remember or not when I showed you that you could put int, float, or str in front of a value which is in brackets and change the type. That would be a way to fix this. You could make that 5 a string value by putting it in brackets and putting str in front of it, and that would fix this problem. If you did that, you would have a string on both sides of your plus sign, and it would know it's supposed to concatenate. Just like the plus sign can be two different things, that asterisk can be two things as well. With numbers, you're multiplying, but if you have a string on the left and then an integer on the right, you're using a different type of operation with the string. What you're doing is you're repeating it. It's called the repeat operator. So you're repeating that string the number of times you have on the right hand side. So in this case, 3, hello world, hello world, hello world. I can't think of an actual purpose for this operator right now, but maybe we'll see something later. We're back to talking about an index again. And by the way, plural of index is indices. So in this case, we have two integers in those square brackets, and it's referring to two different indices. So the 3:10. So index 3, so y for 0 is 0, e is 1, l is 2, the second l is 3. So starting with the second L in yellow, we're going to take those characters until we get to the 10th index, which is the M. But we're stopping right in front of the M, and we're going to take that slice out of our string yellow submarine, and we end up with low sub. So if you subtract 3 from 10, you get 7. And if we count the characters that we copied, LOW space SUB, we end up with 7. So when we take a slice and we have both integers in our square brackets, if we subtract the first from the second, it tells you how big our slice will be. So in this case, 7. If we're missing the second integer, we're going to go right to the end of our string. If we're missing the first integer, we're going to take it right from the beginning up to, but not including, our 10th index value. So to summarize what we talked about with our string functions, we can get the length by using the len function. We can look at the character at an index by using those square brackets. We can concatenate strings by overloading, well, because the plus sign is overloaded and it'll work as addition for math or concatenation for strings. And same with the asterisk, it's also overloaded and it will repeat our string if we have a string, or it'll be used for multiplying if we have two numeric values. Pseudocode is a very cool thing to use. Sometimes it's a lot easier just to kind of write out what we're talking about and then look at the actual, what we call syntax of the language. So if we want to get the length of a string, we might write the whole word length, but that's not going to run if you type it into our Python environment because the syntax isn't correct for Python. It's just the way we would say it if we're speaking English. Okay, so let's use some of these functions we've learned about. Okay, so we're putting some functions together again using the output of our function as input to the next. Starting from the innermost bracket, we're going to let a user input a number. That number, when they input it, it's actually a string value, so that has to be converted to an int before it can be multiplied with the 2. In this case, we enter a number, and there's no conversion to an int or a float, so we have 2 times a string value. So the multiplication sign here is not a multiplication sign, it's a repeat. And we're going to repeat our string value twice. Do you understand what's going on here? We're going to take the length of our string, mystery, which is 1, 2, 3, 4, 5, 6, 7, and we're dividing by 2. In that division, are we going to get a float or an int? It's 1 slash, so we get a float. 7 divided by 2, well, you do the math. Then we take the floor. I haven't talked about floor, but if you were in an elevator, and okay, I guess I will have to do the math. 7 divided by 2, well, if I take 6, I get 3 and a little bit more, so 3.5. So 7 divided by 2 is 3.5. Okay, so that piece is done first. If you're on an elevator and you are at the 3.5 spot up your building, what floor is at the floor and what floor is at the ceiling of your elevator. Well, below you is the 3rd floor. Above you is the 4th, if you're at 3.5. So floor is when you go down from your number. If you're at 3.5, floor will take you down to 3. So once you finish that, math.floor, that's 3. 3 is now used. If you look at the 3rd line of code there, it's in square brackets. So the 3 is the value for the index for mystery. So which letter are you going to get? M is at 0, Y is at 1, S is at 2, and T is at 3. This should produce the integer 3. Did you guys figure that out? Wow, that was a lot of work.
So here's an exercise for you. Very similar to the slide we just looked at. There are a few things to figure out using floor, which is a string function, using length, which is a string function, divided by, and the indices for strings. Can you put all that together and figure out, look at those first 4 lines that are there. What's the result of each of those? And what will this print out in the end? So your task is to figure out what the print instruction is going to end up producing for us. Take note that it was very long, so it's been joined together, those 4 lines that you see print and then the 4 lines there, they're all one instruction. So they're joined together with the backslash. So good luck and submit your answer in the Google Classroom when you're done.